I will continue here. See, for the unit deformation generated at in the direction of the 1, the force in the direction of the 1 is 12a by L cube, 12a L cube. In the direction of the 2, 6a by L square. In the direction of the 3, 3 is a vertical force. See, vertical force, not a vertical force. Okay, vertical deformation. So it's a 12a by L cube. Fourth is 6a by L square. So if you observe it, the 6a by L square and 6a by L square both are in the anti-clockwise direction. Both are in the anti-clockwise direction. We take an anti-clockwise is a positive. Anti-clockwise is a positive for the stiffness matrix development. So now you can confirm, you can feel it is Ij. If you take it is the force generated, otherwise you can call it as force generated in the jth direction due to fourth generation in the ith generation. Okay, ith, due to deformation in jth direction. That's it, na? That's it. That is a Kij. This K11. K11 means the force generated in the direction of the 1. I call it the force generated in the direction of the 1 due to unit deformation in the 1. Same, the force generated in the direction of the 2, force due to the deformation in the 1. Force generated in the direction of the 3, force generated in the direction of the 4. Those are the things. So that's it. Okay, so now one part is over. The second part, if we take a second means second direction. If you generated a unit deformation in the second direction, okay, unit deformation in the second direction, take it. Second is what? Rotation. So it's a rotation. Second direction means it's a movement, rotation. Give a rotation in anti-clockwise direction. So remaining everything is constant. Okay, remaining everything is constant like this. Give a unit. That's it. Give a unit rotation. That's it. Unit rotation. One rotation. So how much force is required? How much force generated? You already know it. No need to remember. So you already know what you know. So if far end is fixed giant, how much force required to generate a unit deformation? It's ml by 4ea. You already know. ml by 4ea, ml by 3a, already you studied in slope deflection method. The same, if you generated a unit deformation in this direction, the force generated is 4ea by L. ml by 4ea, already you know the slope generated is ml by 4ea. So if it is a 4ea by L, in the same direction it's a 2ea by L. You already know. That's it, na? So that's it. And also forces, there's moments is generated, and also shear force. So 4 plus 2, 6ea by L, and into multiply with L square. So this direction it will come. So that's why it will. That's it, na? 6ea by L square and 6ea by L square. That is the equilibrium. You already know these values. 4ea by L. So that's it. If now if you write it, K1 in the 2, stiffness generated in the direction of the 1, due to deformation in the second direction. K12 is what? 6ei by L square. You already know. So next K22. So what is that value? So deformation in the second direction, the force generated in the second direction. What is that value? 4ea by L. Understood? 4ea by L. So next K32. What is that value? K32. So third direction. So 6ea by L square. But it's a negative. 6ea by L square. Fourth is a 2ea by L. You already know it. That's it. That's it. So now if you go to third and fourth are similar. Third and fourth are similar. So I will give third. Give unit deformation. So unit deformation, how it generated, how it okay. So like you can write it 6CA by L square, 6CA by L square. That's it. So moment is, that's it. It's a 12EA by L square. It's a 12EA by L square. That's it. Same. This is unit deformation. Right? K13. K13 is what? It's negative. That's it. 12EA by L square. K23. It's also negative. 6CA by L square. K33. K33 is a 12EA by L square. L cube. K43 is minus 6EA by L square. That's it. So again fourth, if you write it fourth, unit deformation in the anti-clockwise direction. So generated, it's a clockwise or anti-clockwise. Anti-clockwise, you required anti-clockwise. It's a clockwise required. We required anti-clockwise. So anti-clockwise required. So this is a clock. This is one. That's it. Anti-clockwise. So how much force is developed? You already know. This is 4EA by L. This is 2EA by L. So this is 6EA by L square. This is 6EA by L square. Okay. So you can write it otherwise. So now if you see, what is the stiffness matrix of that element? Stiffness matrix of that element, see. Stiffness matrix of K11, K, see, K11, K12, K13, K14. Otherwise, see, this is K11, K21, K31, K41. What is this? This is related to the first deformation. This is related to the first direction. Unit, if you develop a unit deformation in the first direction, these are the values. So write down directly. No need of those things. Write down 12EA by L cube, 6EA by L square, minus 12EA by L cube, 6EA by L square. That's the first. That is second, 6EA by L square, 4EA by L, minus 6EA by L square, 2EA by L. Next is 12EA by L cube, 6EA by L square, 12EA by L cube minus 6EA by L square, 6EA by L square, 2EA by L, 6EA by L square, 4EA by L. See, this is a symmetric matrix. Or observe it. That's why I didn't write those fourth, because just I want to show you this stiffness matrix. So everything is, see, stiffness. Just observe it. This is exactly this. This is exactly this. This is equal to this. This is equal to this. So diagonal elements, if you observe diagonal elements, everything is positive, because what is a diagonal element? K11, K22, K33, K44. The force generated in the direction of the 1, when the deformation in the direction of the only in the 1, or II, JJ type. IIJJ type. Okay, so if you applied a force in the direction, the deformation should be in the direction of the force only. There is no chance to the opposite direction. So that's why everything is positive, but remaining may be opposite. Opposite direction. Forces may be generated opposite direction. So that's why the remaining quantities may be positive or negative, but the diagonal element should be a positive. And also, what is this, sir? These are the C. These are the shear force in the direction of the one. Otherwise, okay. These are the rotation. Rotation. These are the not a rotation. Okay, taken. These are the third direction. These are the fourth direction deformation. So you can call it as this is a vertical displacement. Are understood? This is a vertical displacement. This is a rotation. Second, third also vertical. Fourth is a rotation. Otherwise, you can call it as node. If you call it as a node, first node. This is also first node. This is second node. This is second node. You can write like this. Okay. This is the stiffness matrix. This is the stiffness matrix of every element. Every element is taken as the same thing. Now you can apply, you can develop a flexibility matrix for the same flexibility matrix. Sir, how can you apply a flexibility matrix? Sir, flexibility matrix, see if it is this element. If you applied a unit force, in the direction of the one, you have to find out the deformations developed in the first direction, second direction, rotation, third direction, fourth direction. Sir, how it is differ? How it is differ? It will go to this or it will go like this. Sir, how it is? Sir, it is not possible. Why, sir? There is no restraints. Okay, we have to release the forces. There is no force developed, only deformations developed. Okay, if you applied a unit force, here one delta, one rotation, here another delta, another rotation. It is generated, but there is no stability here. How can it? You can't develop. So that's why flexibility matrix you never see a flexibility matrix. If you search in a Google, so bending flexural flexibility matrix, if you saw it, there is nothing. But you can inverse it. You will get it. But that is the imaginary thing. Are understood? If you get the inverse of this matrix, you will get a flexibility matrix. But that is an imaginary. In real, you can't. But if you restrict others, you will get it. Sir, how can? If you restrict others, if you give a unit force here, if you restrict here the deformation also, you will get like this. You will get what? L cube by 3a here. Slope is L square by 2EI here. If you restrict these deformations, in previously, if you see, if you applied a unit deformation in this direction, you restricted forces, you restricted deformations, everything is deformations, but you allow forces. Here, if you want to develop a flexible matrix, you want to allow deformations. Same opposite. You have to develop. Wait, what happened? You have to develop. You have to. Okay. It's not possible to develop like this. At least you have to restrict others, then only you will get it. So individual, in certain cases you will find out, but in an overall flexibility matrix you can't find out, but directly you can inverse this matrix, you can find out, but that is imaginary. That's why no chance to do flexibility matrix. If you see any finite element analysis, everything they use a stiffness matrix only, not a flexibility matrix. Okay, so that's the one thing you have to understand. There is no flexibility matrix for this type of 4 by 4 matrix. You didn't get it anywhere for a single flexural element. Okay, You will get it like this. Okay, otherwise like this also you will get it. If you applied a unit rotation, unit force, how it differ, you will get it differ. If you want, if you restrict those, in reality you have to allow those also. If you applied a unit force, unit moment, so what is it? 4 by L you will get L by 4 that is the rotation you will get here. Here also L by 2 off, sorry. So what you will get? Slope ml by 4 so you will get, what is that? This is half of that, ml by 4 and L by 8 so you will get, this is if it is a unit force here, so the rotation is theta, this is theta by 2, you already know it. If you allow, if you allow, but these are not, if only individual elements, those are the, if you take an individual cases. Okay, those, that's why flexibility matrix is not. So you, I want to explain everything, total overall idea. Okay, so now see, one thing is we completed. What is the completed? Discretization is completed, matrix developed, flex stiffness matrix we developed, assemble of the elements, assemble, we have to assemble. So now we have to assemble. See everything you observe it. Now I will explain another. So this is 1, this is 2, these are the elements, 1 2 3 elements. These are the nodes, okay. So I will call it as a matrix a, this is B, this is C, like this, just observe it. Okay, A B C, A element B element, this is a node 1, node 3, node 3. For node, for the element A, how it is right? For the element A, how it is right? So see, these are the structure, you feel it. Just recall the slope deflection method. This is the same slope deflection method here. This is the same slope deflection method. Just recall the slope deflection method. If the load is like applied, anything load applied, something like this, something is there, what we did, every element we just ticket, we just feel that fixed end moments we calculated na? We just calculated fixed end moments, fixed end elements, fixed end moments. Okay, or observe it. Why? So for the load, for the load application, first we just taken it as a, every rotation, every deformation is restricted, we will get something forces. Are understood? Every deformation we just restricted, we get certain values. Those values are fixed end moments, we call it as a fixed end moments. So fixed end moment. So for this is the color, this is a force, this is force application. Just recall, this is a force application. Are understood? Every deformation is restricted, we taken as a fixed end moments or fixed end forces. You can call it as, this is VA, VB for A element, so or other V1. Okay, this is, you can call M12, this is good, M12, M21, M23. Okay, so this is V A element, this is VB element, 1 1. So we restricted every deformation. Later, by the application of the forces, the deformations are not restricted, they are deformed. So we release those. Next we release those. Are understood? Next we release, like how it released. We released something like, we released maybe how much it is. So something here is delta 3, delta 2. We released. By the release, how much force is generated? And the final is this one, Without, this is a force application, this is a response. Are understood? This is a response. This is a force application. Everything is restricted. Slopes and deformations, everything restricted. We find out those values. Later we release those deformations. Maybe if it is a free giant, if it is there is no support, it will go like this. It has some deformation also, like this. Everything is released. By the release, how much force is, how much responsible force is generated? Can you calculate it? We calculated like this, something value for this, for this it value. So we generated 4a by l, 6a by l. We generated. Later we write it. MAB final moment is fixed end moment plus by the release of these deformations. What is that release? 4ei by l into theta a plus 2ei by l into theta b. We write it by the releasement. If it is released here, if it is also released here, everything. Later we applied end conditions like theta a is 0 or theta c is 0. These are the end final, that is the final moment. See, boundary conditions. Okay, so this is a, we write na, slope deflection moment. Exactly, slope deflection method we write like this only. Here also same thing. Otherwise I will show what I explained. I explained excellent. I feel better. So for the individual ML by 4A, those are these things I developed. See, here I show you. Here I show excellently. So beautiful, I think. First we restricted everything. We developed those movements. Later, final, the release of those due to application of the forces. And final, the deformations are released. Due to release, how much force is generated, the resultant only we write it. Okay, that's it now. That's the only slope deformation method. So if you include this also, support settlements. Okay, so I explained previously. If you want, go to check it. Okay, so now if you see just stick those values. Just these matter, just keep aside. I will show you this. So generate, take one element, take this first element like a, just take it. Okay, so how you can write the final moments MAB. So not only moment, v the first element, first node, v the first node, m the first node. Are understood? So these are the final. So this is a force and this is a response. These two resultant, if you add those two, you will get final. So these are the final. I said these are the final. V, two element with respect to a element, see, two node, and m with respect to 2 with respect to a node. These are the final. So how can I write? So just keep aside these value, only this taken, only response is taken. Just response, how it is, what is the response? These are the response now. The force generated by a unit deformation, this theta a into 4a or theta, see this value, this is the stiffness, already know this is the stiffness related to that deformation. That's it now. That's it. So this value is exactly the stiffness of matrix of that element, K11, K12, K13, K21, K31, K41, K14. So exactly every element has same stiffness only. Difference is only boundary conditions. I will explain. So if you see, this is a delta 1, theta 1. This is delta 2. This is theta 2. You already know. This is the response. So m1 is what? M1 related to the delta, this factor multiply with these element, this response. And so K21 multiply with delta 1, So this K22 multiply with theta 1. K22 is what? How much amount is K22? You already know. 4A by L. 4A by L into theta A. You already know. Same. 4A by L into theta A. So next K31. K3, say K23. K24. K24 is what? See, 2A by L. 2A by L into theta. Sir, what is delta 1, delta 2? Delta 1, delta 2 is there when the support settlements are there. Support settlement are there. Everything is same slope deflection method only. If the support settlement is there, you will get this 12A by something is, what is it? Support settlement is 6A by L into delta 1. 6A by L square into delta 2. We same write in a slope deflection method also. Are understood? We write in a same slope deflection method also. See, 6A by L square. The same thing we replicated. Okay, here only we will develop it for the moments only. Now we develop the shear forces also. Not a shear force, support reactions. Okay, so that's the idea. Slope deflection method only. Are understood? So that's the exactly. This is the stiffness. This is the final, sir. If you call it as this is the final. So where it is? Where it is these fixed end moments, sir. Fixed end reactions. If the supports deformations are fixed, these are the deformations, are everything is fixed. We develop this, and if deformations are released, these are the both two combined. If you combine those two, you will get final. That's it, na? This value. So this value and this value combined, you will get final. So what is these values? These values you have to combine it. Combine it. Combine it. What is that? Forces. V1 force. Okay. M1 force. These are the final. You can call it as final. These are the fixed end moments. So V2 by A matrix. M2 by A matrix. So these are also taken the same direction. Same direction means VA. If you taken upward is positive, M is anti-clockwise is positive. If you taken anti-clockwise is positive, not a clockwise positive, that will adjust in X problem. So this is for A matrix. See, for the element of A. For the element of A, just observe it. This is for the element of A. Okay, for this element of A. Taken if now element B. Element B also will get the same thing, na? Same thing, but element B has, this is a node 2, node 3. So now we will see, this is, you will get V2 for B, V2, see, M2 for B, so node 2, V3, M3. You will get it like this. Stiffness matrix is same here. Stiffness matrix is same. Stiffness matrix is same. So now we will get 2. So now it's a 2, 2, 3. I will call it. Same matrix. No well, just matrix is same, but see the length. If it is length is changed, length and EA is changing. Those values are changed. Length and EA are changed. So that element has stiffness matrix will change only if the length and EA change. Okay. So just observe it. Just observe it. So here also you will get delta 2 for B element, theta 2 for B element. Okay. These are the for A element, B element. Okay. So next 3 delta 3. Same fixed end moments will also say V2 for B element, M2 for B element, V3 for B element. Everything is B element. Okay. M3. So this is for B element. Sir, how we will connect it? So now you observe it. Just observe it. This theta, these delta, see, for the B element. These theta, these delta and thetas are both are equal here. Because the joint is same. The joint is same. This is a joint. Understood? This is the joint. The joint has only one deformation, maybe if it is support settlement is there, and it has only one rotation. Both are same. Both are same. That is the connectivity between A element and B element. And also, and you have to understood that the reaction at that joint is V for A element, V for B element. Both you can club it, only you will get the reaction. Are understood? The moment also, the final moment also, if you already know it, final moment also, MBA plus MBC, you have to add those two. Sir, if you add those two, it's a 0, sir. Because MABA, MBC, both are equal. Yes, I know it. Same as a reaction also, as a reaction you have to add it. The moment also you have to add it. Then only that is the moment. So if you generally observe, the moment here is released. If you release the moment only, you will get the deformation. If you restrict the moment will generate. If you restrict the rotation, then only moment is generated. Here we release the moment. Moment is 0. Generally MBA is there, MBC is there, both are opposite to each other, equilibrium equation. Okay? Just add this because the connectivity is B. You have to add MBA and MBC. Final MBA and BC. The reaction is VA and you have to add it for the joint. Joint is connectivity. So you have to add for the AB, if it's taken as a AB. So now you can see, observe it. The total for the A element and B element, if it's taken as a total, this is the element. Total, how many deformations, how many degrees of freedom is there? Here, 1, 2, 1, 2, 1, 2. 6 elements are there. Six deformations are there. But total combined A and B, you have to combine it. You will get 6 deformations. You will get 6 by 6 matrix. 6 by 6 matrix means delta 1, 1, theta 1, delta 2, theta 2, same, delta 3, theta 3. You will get 6 by 6 matrix. So you can write 6 by 6 matrix. How can you write, sir? How can you add it? Just add these two, just enough. V to A and these two. And M to A, M to B. You have to add it. You will get that. Sir, how can you add it? So just I will write V to A. I will write it. For A, what is that here? Just this element, multiply this value. And then, so K31, that's it. So delta 1, are understood? K32, theta 1, K33, delta 2, K34, theta 2. That is the K21. So minus that value, I will explain. That's V. What is that value? V to A. That's aside. Keep aside. So okay. Here V to B. You 12. V to B. How it is? Same here also. V to B. What you will get? These matrix. So again, once again, I will write, this is like a 1, 1. 1, 1, I will only write it like, I will write like 1, 1. Just it is. 1, 1. So this is a theta. See, this is a delta 2. This is a delta 2. 1, 2, theta 2. 1, 3, delta 3. 1, 4, delta 3. V to B. Just you add just to these two. Add these two. Just add these two. You just observe it. You will get what? This theta 2 plus, add it. You will get what? K31 delta 1. This K11 delta 2. Here, this is for B element. Okay. This is for B element. This is for A element. So this one add. This one, everything you can add it. Just observe it. These delta 2 are same. Are understood? This theta 2 is same. Okay. These are the same. Now you can observe it. Directly you write those two. 3, 1 delta 1. 3, 2 delta 2. These are the same, na? these 3, these 1, this K34, this K12, again these 2, again these 2. So you can add those 2. So now the shear force at that location, location of the giant B, are understood? So you can write in terms of delta 1, theta 1, delta 2, theta 2, delta 3, theta 3. 6 deformations. Now we write in a matrix form. These 3, these 6, delta 1, theta 1, delta 2, theta 2, delta 3, theta 3. So yeah, previous same 3 1, the 3 2, but here only you will get theta 3, next theta 1, next 3 4, K12. Just principle of superposition, just explained. K14, sorry, 1 3, K14. Here only you will add these 2. Here, see, now you can observe it. Previously this, what is the add? K33, K11. Here just observe it. Here these parameter, here parameter, and here this parameter will add it, will add. That's it. The same thing next. K34 and K12, these two will add it, are understood? So for the M2 also, this value and this value will add, this value will add. So this last 2 will add these 2. That's the only connectivity is these 4 values will add to these 4 values. That's the connectivity between element 1 and element 2, because these 2 are same with respect to these 2. These are same. Okay, so now you can write down the final stiffness matrix, V1 first element, V2, not a V2, M1, V2 direct final, you can write M2, V3, M3. If you write it, so previously same. So 12 EA by L cube, these are the related to A. You can just I will write these in a white line. So this related to A, because A has certain different length and B has a different length. Maybe A has different A, B has a different A. Only change will come. See, 12A, 6EA. So I will write like this: 1 2 3 4 5 6. I write this is called delta 1, theta 1, delta 2, theta 2, delta 2, theta 3, minus 12EA by L cube, 6EA by L square. Sir, what is these 2 values, sir? There is no relation between V1 with respect to delta 3 and theta 3. Are understood? There is no relation. Just V1 is just something. See, V1 is these only, these factors, just these factors, multiply these factors, you will get V1. For the V1, there is no relation between these 2. Only between A matrix and B matrix, relation between only V2A and M2A and V2B, M2B, because this theta 2, this delta 2 and theta 2 are same. So there is no relation between this V1 to this delta 3. Okay, there is no relation. So these 2 are kept as at 0 0 0 0. Same M1 also for this 6EA by L square, 4EA by L, minus 6EA by L square, 2EA by L. These 2 are kept. For the V2, now we can write V2. Is, see, K31, for the A element. For the A element, so this is a 12 EI by L cube minus 6 EI by L square, because these two, for these two, this is a 3A1, 3A2 for the related with the A element. A element, and these values change for the A element, B element, because L may be EA change. So this next K33, what is the 33 value? Is a 12 EI by L cube. For the A element, you have to add next K11. So I will add like this. I will add 1 means this is again, for this is a B, 12 EI by L cube. Maybe this is for A, this is for B. Understood? Maybe L may be changed for element. This is the total stiffness here for that joint. Next 3 4. Next 3 4. It's a minus 6 EA by L square. Minus 6 EA by L square. Okay. So next 1 2. This is 6 EA by L square. Okay. Now just observe it. Minus 6 EA by L square. Where it is? Plus 6CA by L square. Sir, both are same, sir. No, these 6A may be different. These 6A may be different because L may be changed. This is for A, this is for B. Next, once again, K1314 for the next element, these values. So 12 EI by L cube, directly these values 13. So again 6 EI by L square. These two will come. Because this V2 is not only dependent on A, it's dependent on B element also. So that's why these four, again see just these four only, these four only for the B element. Just add it. For the M2, again same, M2 again same, 6A by L square, 2A by L minus 6A by L square. You have to add these value 6CA by L. This is for a B element. Okay, so for the A element, so finally it's 4EA by L. 4EA by L. Here equals to 4EA by L. 4EA by L. So again, just add it. Again, this same will come. 6CA by L square, 2EA by L. So next, V3 M3. V3 M3 has no effect on delta 1, theta 1. V3 M3 has no effect on only delta 2, theta 2, delta 3, only effect. There is no effect on theta 1, theta 2. So delta 1, theta 1. Okay. So that's why it will come like 0, 0, 0, 0. You will get only minus 12 EI by L cube minus 6 EI by L square, 12 EI by L cube minus 6 EI by L square, 6 EI by L square, 2 EI by L minus 6 EI by L square, 4 EI by L. So just observe it. This blue line, see these yellow lines, again these yellow lines again, it's the same matrix. Are understood? The same matrix what I write in white line, I add here for the A element, B element. Or observe it. This is exactly, so I will strike out these things. Later you will see. Are understood? This thing and these thing are understood? I just add it. So why it is added, sir? See, these are the relation. Okay, I just add. If you want to add a third element, now here you will add again, it will come. If you want to add another element, so addition will come only these two parts only. Are understood? That is the addition, principle of superposition. So why it is these parameters are answering? These parameters are delta 1, theta 1, delta 2, theta 2, delta 3, theta 3. Okay, so these are the summation, these values multiply with these values, you will get v1 final. And also finally I said final, so final you have to add these fixed end moments also, these fixed end moments also. What is that fixed end moments? These values na v1, these are fixed, v1 m1 here, v2 for the a, v2 for the b, m2 for a, m2 for b, fixed. Here v3 em3, you have to add those values. This is a response, this is the application this is applied, this is a response, resultant only will get final values. Okay, here also applied force is taken as a positive, anti-clockwise is taken as a positive moment. And if you see it, if you want to take, and sir, how we can solve these 6 by 6 equations, sir? Now if you see the 6 by 6 equation, finally you reached like a 6 by 6 equation. Okay, it's a 6 by 6 equation. Sir, how can we solve 6 by 6 equation? That is a question mark now. So the final is, now you can understand, apply a boundary conditions. Apply a boundary conditions. Now I will take an example not a problem. Anything it's a should be is in stable. If it is a problem, this is a problem, this is a problem. Now if it is a problem, you already know it. Final boundary conditions what? Here delta is 0, theta is 0, here delta is 0, here delta is 0. Okay, so now you can feel it as 1, this is 2, this is 3 element. These 3 nodes, delta if you taken like this, theta 1, delta 1, delta 2, delta 3 are zeros. 4 zeros are understood, 4 zeros. Now you can strike out 1 0, 2 0, this is 0, this is 0, only 2 will remain. Sir, okay sir, you can find out these values, final and fixed end moments you can find out, fixed end forces and fixed end reactions you can find out. Okay sir, this is a force vector, this is a final force vector, this is a fixed end force vector, this is fixed force vector, this is also forced vector. How can you solve, sir? I will show you. So one thing you have to observe, exactly very best line, the line is very best. One thing you have to understand it, the very good line. See, if the deformations are released, forces will develop. No, if the deformations are restrained only, forces will develop. Understood? One thing you understand. Here you see theta is restricted. If you restricted only, you will get a force. If you release here, there is no force, there is no moment. There is no moment. Yes. If you restrict, the forces will generate it. If you allow it, there is no forces generated. So you already know in temperatural stresses, if you restricted only, forces will generate it. If you allow it, there is no forces generated. So by this assumption, not assumption, by this exactly rule, here you will already know final end conditions, final moment is 0 here. You already know this is a moment is 0 here, and also here is also moment is 0. Sir, we have a moment here, sir. Yes, you have a moment. What is the moment? M21 is there, M23 is there. If you add it both, you will get 0 only. This is the equilibrium equation. The moment is 0 in general, because at that location we release the rotation. We release the rotation, that means there is no moment. But you have a moment, and M21 is M23 is there. Both are opposite to each other. So that's why here see M21 and M23. Here you just add these two. Here M2 means what? Here For the A element per B element, you just add it. Final moments. Na? You just add it. M2 is what? Here is M2 is M21 plus M23. You already know it. So we just previously just see it. Here M2A element, M21. Here M2B element. This is M23. You add it na. So these values are zeros. This is a 0. This is also 0. No need at all, because if you see, no need at all assumption. Here the theta 2 and theta 3 are released. The application, the final result is 0. Here you restrain these values, delta 1, theta 2 and delta 3. You restrain these, you will get values. So exactly, that is a exactly beautiful line. Okay, if you release those values, you get 0 force. If you restrain, you get forces. So now we can understand this. Here these two values are zeros, M2 and M3. M2 and M3 is zeros. M2 and M3 is zeros. Here only unknown quantities are theta 2 and theta 3. Unknown quantities are theta 2 and theta 3. Just by the application, by the Norton application, I will write it like this. Here if you see 1, 2, 3, 4, 5, 6, just a matrix form. Here also delta 1, delta 2, theta 2, delta 3, theta 3, plus these values are there. 1, 2, 3, 4, 5, 6. These 1, 2, 3, 4 are zeros. Not only this is some small case. These values are there. These values is 4. This value is 0. This value is 0. How our matrix will solve? The matrix will solve like a rank. You know already matrix properties. The equations you can easily solve. Directly you can take the equation M4. So how can you take an M4? That is a 4. That is a 4, na? That is a 4 is equal to 1 line, 2 line, 3 line, 4th line, 5th line, 6th line. 1, 2, 3, 4. If you see it is directly you can write 4th is equal to, that is 0. 4th is this 4th vector, na? This 4th vector multiply these values. Are understood? So this value multiply with this value. This value is 0, na? 0. This value multiply with this 0. This value multiply with this 0. Only this value, it has this value. This value, this value. Remaining is 0. Are understood? So only this value something multiply with theta 2 and this value just taken this value theta 3. Again this thing and plus something plus this value is there something. Okay, no needed, just take aside. So again this thing 6 also same this thing. Okay, the same thing. If you multiply with 6 again everything is only this value and this value is there, huh? That value theta 2 and this value theta 3 plus this value is there. Just equations. Matrix is just equations. So if you write these two in the matrix form again, just see these 4 and 6. So observe it, just this thing, okay, this thing, theta 2, theta 3 plus these two values, na? These two values. This is 0. You can write like this. Again same, these two multiply with theta 2 and theta 3 again. these two, multiply with these two. So you can write an equation and you can solve it. But by matrix, what my interest is, if anything, this factor is, this value is 0, you can strike out. You can strike out this row and this row, this column and this row. If it is 0, you can strike out and you can strike out. If it is theta 3 is also 0 and the third variable is 0, you can strike out third and you can strike out third. Fourth is unknown value. It has a value, just leave it. Fifth is again 0. You can strike out fifth row, fifth column and fifth row. Only 4 and 6 are there, so you can just leave it a fourth column and fourth row, sixth column and sixth row. Sixth column and sixth row, you can just feel it is. So what are the elements are remaining in the matrix form? Only these 4. So directly you can write down the matrix like this only. By the equations only, that is the main internal meaning. If I just directly said that you can strike out those rows and columns, what is the remaining you can write down. This is a property of matrix. I said like this, it's a wrong, not a wrong. That is the meaning only. If it's just meaning, take it, this is the equation meaning. Just if you write down an equation, it will come like this only. So, but the next time no need to write like these equations. You can strike out those rows and columns. You can directly write those 4 and 6. You can strike out 4 rows and 4 columns, those things. You can, what the left in matrix, you can write theta 2 and you can write. Okay, so these two are exactly zeros. These two are exactly zeros. Sir, every time these are zeros? No chance. So when it is no chance? When it is no chance, if any support, if any concentrated moment acting at the support, if any concentrated moment, if you take an, this is, if any concentrated moment, sir, 100 concentrated moment is acting, that is the value will come directly, this M2. That is the concentrated moment will act. If he has something 50 is there, concentrated moment, the final end moment is 50 only, na? So those will come. So every time these are the not exactly zeros, but every time these are the known values. Not only 4, 6, something based on the degrees of freedom. Sir, why it is come? See this. If it is this is a matrix, this is a problem. If you observe it, what is the degrees of freedom in this? What is the degrees of freedom in this problem? The degrees of freedom in this problem is theta b and theta c only. Okay, the degrees of freedom is what? Theta b, theta c. The kinematic intimacy is 2. So final resultant will come only with 2 by 2. This is a exactly by this, just said in the textbooks, everything, the problem solved by directly by degrees of freedom. What is the degrees of freedom? Sir, 2, theta b, theta 2. So they will directly write this matrix directly. They will directly write this degree matrix directly. So they taken, these are the zeros. These taken, these are the 2 zeros, and they will write these values matrix. They will solve it. But they don't know, they know it, but they eliminated this everything, discretization, elements added, why it is coming, there, everything is they eliminated. You will come across the finite element methods or everything, some other. But this is very important. You can get it if you see any so many problems, if you solve somewhere, you may be confused. Directly they will write like this. But the inner meaning is like this. So if you know this thing, if you know this matrix different, one matrix, second matrix, first matrix, first element, second element, how those join, how they assemble those matrix. Later, if you applied a boundary condition, these are the boundary conditions. Na? If you applied a boundary conditions, you eliminate those rows and columns. You just remaining. What is the remaining? You can solve those two. These are the maybe these known values. These are the known values. Only 2 unknown values. You can solve it directly. You can solve those two. So once you know the theta 2 and theta 3. Once you know the theta 2, theta 3, remaining values theta 2, theta 3. Remaining values you can get it now. M value you can get it. Just multiply these values. Multiply M2 multiply. You will get it. M3, see, M not M3, so M unknown. What is unknown? You can get it. These are the two unknowns. These are the boundary values. These are the boundary conditions applied. Okay, so that is the idea. That is the idea. So you can solve these theta 2 and theta 3. You can get those values by the combined matrix or otherwise individual matrix. Where it is by the individual also. By the individual also, these are also same applicable. By the individual also, you can get it. Remaining quantities. Okay, we can solve only 3 by 3. See why it is by hand. By hand you can solve 3 by 3 matrix only 3 equations. 4 equations also you can't. You can solve by some large. It's taken some lengthy time. So when we take in any problem, see any problem, where is the problem? When we take any problem up to 3 degrees of freedom only we can solve by hand. We will show you in a classroom. But see the assemble of the matrix, if you take any structure, huge structure, degrees of kinematic intimacy, we already solved it. See 30 35 in the first unit. So 30 35 equations, the matrix is 35 by 35. You can see the matrix is directly developed. Everything is directly this developed, and we can add those boundary conditions. So assemble of matrix also is in the code. You can write it in the code. You will give just a boundary conditions and remaining everything is equal. Already 35 equations they can solve by computer. 35 equations, if 35 unknowns are there, they can solve it. But by hand you can't solve. So everything, everywhere, this is the moment. You feel that I said once again, the moment at the joint, where it is, the moment at joint is released. Are understood here? Where I said once again, I said this thing you have to remember forever. Where is the? So okay. The moment here is, if it is the deformity here, the moment is bending moment is 0. That is the boundary condition, sir. Why it is, sir? Here, there, the moment is released, then only deformation will form. So that's why only they will take as a, they're not as taken as a indeterminacy something somewhere. Okay. Here also the moment is 0. Moment is 0 means m21 plus m23 is 0. Both are the same. Both are the same in opposite direction, but it has certain moment. Moment is application. Okay. The moment is not 0. The combination of the giant feeling. Okay. You will understand by later. Okay. By deep meaning. If it restricted here, the force will generate it. Moment is generated. If you allow it, if you allow the rotation, there is no. The same thing here also. If you applied a force, there is no support, there is no reaction. There is no support, there is no reaction. If it is a reaction, if it is support is there, it will reaction. The moment the deformations you restricted, the forces will generated. Okay, the force is generated means the deformations are restricted something. That is a beautiful line. Okay, so by this, the boundary conditions, you can directly comes to this slide. You can, no need of write again these two. This is a meaning. So the problems they will solve in the textbooks, they don't give these type of explanation. They directly comes to this question, this thing. So why they come to this level, how they come to this level, and if you solve by this type of 6 by 6 matrix, I will explain tomorrow. I will explain next class. If I will took on problem, I will show you the 6 by 6 matrix. Later we applied a boundary conditions. Later we will come to this part. And in textbooks, textbooks or otherwise, how they will directly comes to this type of matrix also I will explain. By a stiffness matrix. Okay, by a stiffness matrix, there is no flexibility matrix by a for this degrees redundant, 6 redundant forces. There is no 6 flexibility matrix. You can't find in textbooks on internet because it's not possible. So that's why no computer program possible to do by a flexible matrix. But sir, why it is textbooks? You can solve the problems by individual choice. Individual means I said na previously, if you restricted some others also you can find out. So that's why they will give in a textbook. So how it is a flexibility matrix, we can solve small different cases problems, but overall 6 by 6 matrix you can't find out. Okay. So tomorrow I will solve a problem by a stiffness matrix. Stiffness matrix. By I will show you how they come to the 6 by 6 to the 2 by 2. Later I will show how directly come to the 2 by 2. The same problem now comes to the flexibility matrix. How they will solve, I will show you. Then you can understand exactly what is the flexibility. Later we will go through by flexibility matrix only. Okay. So, and also I want to you the same thing, you observe it. Here a stiffness matrix, unknown forces. See, not unknown forces. Unknowns are, see what is unknowns? Unknowns are rotations. Degrees of freedoms are the unknowns. If you know the degrees of freedom, you can find out the final moments. Flexibility matrix, same opposite, exactly opposite. There are the unknown forces directly. There are unknown forces. How they developed here, how they see, how we come to this conclusion. Same will goes to the flexibility matrix also. Here, here, the same thing. Force, response, same thing. Here see, here we applied a load. We restricted every degrees of freedom. We find out the forces developed. Comes outside. Later we release the degrees of freedom. The forces developed. Resultant. Same flexibility matrix. If you applied a load, we release the degrees of freedom, everything. We want to find out the deflections and rotations. Keeps aside. Later if you allow the forces, how much deformations will come? Keeps aside. So later you can combine, you will get the forces. How sir? Same thing. You see, this is, now you can observe. Here observe, you can, what is the force vector is a stiffness matrix multiply with the rotation, the delta matrix. This is a force vector. Okay, this is a force vector. So these unknowns, k unknowns, this p matrix multiply with this p matrix. Understood? So if it's taken a flexibility matrix, this is a flexibility matrix. These are the forces. These are the deformations. These are the deformations. You want to find out the first deformations, later deformations. By this you can find out these forces. Here how we can find out this. How we can find out these unknown displacements. Here we can find out the unknown forces, but we have to find out the displacements. Okay, how we developed the stiffness matrix, the same way you can develop the flexibility matrix, but not can't it, but by individual choice. Sir, what is the individual problem? How they directly comes to this 2 by 2? I will show the problem by stiffness matrix tomorrow. If you understand that problem, you can just relate it to the same flexibility matrix, you can solve those problems. Okay, that is the idea. Okay, so that's it. If you have any problems or if you have any doubts, ask me. So this is